It's with the immense pleasure that I'm presenting to you the Vice Chancellor of Cape Town University, Professor Mamokgethi. But the pleasure is not only because she's the Vice Chancellor and made all the way from Cape Town to Miami just to present to you, because she's a renowned scientist in math education, specializing in bilingual studies, wrote many books and articles. She was in the program committee of the ICMI conference. She is leading many initiatives in education in South Africa, in Africa in general. She is the winner of the 2022 Inaugural Africa Education Medal Award. So you can imagine that the competition is not easy. She is leading many initiatives, and young people are always inspired by her. And I'm sure that we will also be inspired by her speech today. Thank you very much, my dear, for coming here.
Thank you very much, Mary. Thank you and good afternoon. Whilst I'm starting the talk, I'm going to advise you to make sure that you sit into someone, because sometime during this talk, I want to ask you to talk to someone next to you. I mean, we're talking about mathematics being everywhere, and I'm thinking, who knows and who cares? How do we make those young people who don't know that mathematics is everywhere, how do we make them aware that it's everywhere? How do we make them appreciate that mathematics is everywhere? How do we make them want to get into mathematics? And I think teachers are key to that formula of getting young people into mathematics. And that's why today I want to talk about teaching mathematics being hard. But of course, I have to be a little provocative, knowing that a lot of people here are mathematicians. So yes, I said mathematics is easy, and teaching it is hard. It's because I'm comparing the two practices. I'm comparing the two practices of doing mathematics and teaching mathematics. And let's think about it. What are the differences between the two practices? Anyone wants to try me? The key differences between the two practices, I'm not going to ask for that should be crazy with them. The differences between the two practices, the practice of doing mathematics, the practice of teaching mathematics, what makes them different or similar? Just that anyone who wants to choose. Anyone? I'm a math teacher, I'm used to waiting time. You're teaching young people who are learning mathematics in a language that's not their own, you wait a little more. Shadri, my colleague, by the way, from UCT, she decided to invest on me, you know.
So we're teaching another person and trying to communicate and help that other person understand. Doing mathematics. That would be
okay, that's one difference. Doing can just be you alone. Teaching involves another person. Any other difference or similarity? Yes, ma'am.
They don't understand what they're doing. So then it's sometimes you have patience in your head. Might seem to be the person that they're
all right, so she mentioned the word patience. You could have some patience because you have it in your head, but they don't have it in their head, you say. So you've got to be patient as well. Any other difference? Thank you. Any other difference or similarity? Yes.
just understand it for yourself.
There, now we're growing this difference. She said you've got to understand it for yourself, but when you teach, you've got to understand it so that you're able to share it with someone else. Any other offer? Well, that's why I'm saying mathematics is easy. I mean, as I go along, you'll see what I mean. I mean, we're thinking about mathematics teaching as just imparting mathematics. But actually, in mathematics teaching, we don't just impart the mathematics, we engage with the mathematical thinking of the learner. And so you actually don't know what the learners are going to come out with, and yet you have to engage with it. And if they get the solution wrong, the fact that they got wrong is irrelevant, actually. The big job of the teacher is to diagnose what went wrong, why, and how do we fix it, without just telling what's the right answer, because that doesn't solve the problem. And that's what makes mathematics teaching difficult, because if you know it for yourself, you know that the solution is wrong, and you can give them the right solution. But that's not teaching, that's doing mathematics. And doing mathematics, you can do it, it's you alone. But in a class, even in a class of 25, you can imagine if you have 5 incorrect solutions and they are not incorrect in the same way, and your job is to diagnose what went wrong and then to come up with a way of getting them from there to the next step, then it's not such an easy job. And that's why I'm being provocative. I'm not just being provocative, actually. I'm saying to you, it's great. The math teacher has got to know the mathematics for themselves, but they've got to do much more than that. Knowing the mathematics for yourself is not good enough. And that's what makes mathematics teaching harder. And so in my job, in my daily life, I'm in a quest to recruit more people to join mathematics teaching, to take mathematics teaching as a profession, and to get mathematics teachers to be seen as people who are doing really an important job, and not such an easy job, because it's very easy to think that teaching mathematics is easy and we just teach you the mathematics, you do it. So mathematics is not difficult, and so after this little interaction, we can agree that it is not so difficult. But of course, a recent report by the THE Journal, which discusses transforming education through technology, says that a survey of 900 high school learners in the United States found that confidence in mathematics drops by 9% between grades 7 and 10. And overall, less than 20% of students in grades 7 to 10 are confident in their math ability. And in my country, South Africa, the mathematics pass rate for high school matriculants has been steadily dropping year after year. In my experience, first as a high school teacher and as a school principal, and later as an academic and researcher in mathematics education, I've seen how many young people are scared of mathematics. And it is because of who introduces the mathematics to them and how they do it. That usually is the key as to whether young people are going to love mathematics or not. Before they even really know what mathematics is about, many learners form a negative experience with the journey of mathematics before they even know. Why? Because in many societies, I don't think it's only in South Africa, many people feel proud to stand up and say how bad they were at mathematics. I mean, many of us studied mathematics in this room, and if you're a maths professor, family gathering, professional, any gathering I go to, anyone who hears that I'm a professor in mathematics, before they even hear education, they go, "Ooh, she's so smart. I was never able to do mathematics." No one ever says, "Oh, I could never even do biology." No one tells us how difficult accounting was, but saying you were never good at mathematics is a badge of honor in any country. Certainly, I've traveled all over the world. People treat it as a badge of honor. And so, my punchline is, if you have nothing good to say about mathematics, say nothing at all. I say to CEOs, I say to politicians, to presidents on my continent, you only talk about mathematics if you've got something good. If you've got nothing good to say, we're not interested because we don't want to know how bad you were in accounting. So it stands to reason that could change popular perceptions and students' performance in mathematics, we need to change the way it is taught. And all of us who are mathematics teachers, and this includes mathematicians who teach at university, we need to change the way it's taught. We need to make sure that we deal with this negative perception of mathematics. Otherwise, where will our future STEM professionals come from? How will human beings thrive in an increasingly science and technology-based world if they're afraid of mathematics that form the foundation of the innovations that they need to use? How will previously marginalized groups be able to influence how science and technology will operate in their home communities if, in fact, they're scared to even try it? But what makes a good mathematics teacher? Being a good mathematics teacher involves more than just being a good mathematician. Just as we had that conversation, it involves more than just knowing it for yourself. It is much more than just knowing and being able to do the mathematics for oneself. Excellent mathematics teachers are not just well qualified in mathematics. They are also well motivated. They are passionate about their subject, professional and compassionate towards their students. Someone talked about patience, hearing, understanding where they come from. I mean, all of that stuff is like stuff that psychologists and social workers do, right? You're going to do that as a math teacher. Like if the children are boring you, that's your problem. You know, so you devise all sorts of gimmicks to make sure that they're involved. I mean, one of the things that I learned to do as a young mathematics teacher, working with children in the farm schools and teachers in the farm schools during apartheid in South Africa, I figured that the children don't care about mathematics. They don't think it means anything to them. So make them love it first, because once they are hooked, then they will want to do it. I don't force them to do it. I find a way to love it. And then they are hooked. Even when they can't do it, even when it's difficult, they want to do it because they love it, right? And the challenge of a maths teacher is finding a way to make them love it. And we'll do a few things just now. Every teacher of any other subject, of course, needs to be motivated to engage or to change the lives of their students in positive ways. If, like me, you have experience in teaching mathematics at school or university level, you will know that there's a big difference between being able to solve a problem for yourself and being able to teach a student how to achieve that solution on their own. When you do the mathematics for yourself, you use approaches and methods that you are familiar with. But when you are teaching, you have to put aside your familiar approaches in order to observe and understand the different problem-solving approaches taken by your students, some of which may not even be familiar to you or comfortable, or you may not even be comfortable with. The students' approaches to mathematical solutions are not always correct, and some of those approaches will be entirely inappropriate, while some may be partially correct. And as a teacher, you have to be able not only to discern the right thinking from the errors, but also where those errors may have been introduced in the student's thinking. And that's the part that I was talking about, that's diagnosing. So being a teacher of mathematics is like being a doctor in my view. It's like what the doctor does. Okay, you have to diagnose what foundational concepts a student is working from, isolate the source of the error in that student's approach to solving a mathematics problem, and develop a corrective procedure to correct the error. This is why sometimes even the best mathematicians might struggle with teaching, because teaching is not just about the mathematics. It is also about the student, who they are, what they can relate to. A good teacher needs to take time to understand how their students are thinking, how are they thinking about the problem and its possible solution. And I'm sure many of you might have been exposed to the work of Deborah Ball, a well-known American mathematics teacher and researcher who shares a global concern for students' reluctance to study mathematics. As early as 1988, she wrote in her doctoral thesis, as an experienced mathematics teacher and late blooming mathematics amateur, I too worry about our culture our culture's mathematical disenfranchisement and disenchantment, close quote. Deborah argues that mathematics teaching involves more than just recognizing that a student's response is wrong, okay? Or quality mathematics teachers will identify the source of the student's error, then start from where the student is, move from them towards appropriate ways of solving the problem they are dealing with. And today, I would like to discuss with you some of the ways in which my colleagues at the University of Cape Town approach some of the teaching of mathematics and related subjects. So I'll share some of the quotes from my colleagues, some of who win Distinguished Teacher Awards, but I also want to share some of the examples of what teachers have to deal with in a mathematics class. But let me start with the quote by Annelies Schoeter. Annelies is a very popular mathematics teacher, a mathematics lecturer at UCT. She teaches first-year students, and not only the ones in the math department, but she also teaches the ones who come from engineering. Oh, I'm trying to take it back. How do I do that?
Stop share.
Okay, do I do stop? Okay. All right, I don't want to take it back. I want to take it to the previous slide. Yes. So there, I want to share that, but I just wanted to do that. I'm not going to share with you what Annelies says. It doesn't matter. But the interesting thing about Annelies, I mean, I've got children, right? And one of them was taught by Annelies. When Annelies won the Distinguished Teacher of the Year award in 2019, I asked my son who's doing civil engineering, the engineering students. Actually, let me take this off because you're not listening to me. And I can see that you're already there. And I asked my son, what is that about Annelies? Because when you meet Annelies, Dr. Schreck, she's very reserved, very quiet, and my son's that. My son's doing civil, right? Not math major. And engineering students struggle with physics and math 1 because they go to pass. And she says, you know, Ma, Annelies makes me feel like I can do math. Even when she invites us to ask questions in class, you feel that your question matters. She said, you ask a question that you think is stupid, and she said, wow, that's a great question. She said, just that deals with me, because all these professors don't do that with us. Some of them tell us, you're supposed to know this. How can you even be here? How did you even get to this part, right? And she said, first of all, that's the plus. Right? And then she said, you know, we're doing engineering. Yeah, about these kids. But Annelies introduces the topic and then tells us why we, as engineering students, have to know this. Where are we going to use them? So, listen, once Annelies has done that, I listen now with the ear of how is this going to work on the construction site. Because Annelies has sort of made it clear. So she doesn't just teach me this concept, but it makes me realize how important it is for me. And then she said, Annelies also doesn't think she's the best teacher on earth. So if she's teaching us this day, she gives us notes of the lecturer who taught the class last day. She said, you might not understand mine. So we have these ones. Maybe you might understand these notes from another lecture. She says, wow, the other lecturers make us feel that they are wrong. So Annelies says, if you get mine, here's other. So I don't to mention other things. And she said, when the lecture ends, Annelies stands at the door and she waits for them. Oh, hey, you can join the class. This is the first year next class. Often with 300 students here at UCT, we've got a nice problem at UCT of overcrowded network classes. I think this is not a nice problem, but we have that, and she stands at the door to do that, right? So So there are many other ways that lecturers in a mathematics class makes students feel valued, feel that their thinking is valued, and so on. So now I want us to look at this one little problem. And I'm giving you just, these are high school problems so that we can all get into. And this one is on decimals. This is one of the things that teachers have to do, that mathematicians don't have to bother about this. If you wanted to understand how to put the decimals in descending, basically, if you want to know which one is bigger than what, which one, which set is best to choose. You know, a mathematician doesn't have this problem. They don't have to decide which one to choose because they know which one. They know the decimals. But if you are a teacher, which of the following lists of numbers would you give to best evidence of learners' correct understanding, and why? Which one would you choose if you wanted the learners to see whether they understand how to put decimal numbers in descending or ascending order? Which of the following list of numbers would give you best evidence of learners' correct understanding? It does matter which one you choose. Yes, sir.
Take B.
B, tell us why.
Because they all have the same amount of digits.
They all have, they have 3 digits each.
And they all get common.
And why? Why do you pick the ones that have got 3 digits? Why does it matter?
I know mathematics doesn't matter, but the children it matters. They see different longitudes of numbers get confused.
Okay, that's your thoughts. Let's hear other thoughts. Yeah, which one? Yeah. A.
If they had intended because they're like a little tricky.
They're tricky.
They had to think about it, but really have like different numbers. Like, you know.
Okay, that's another idea. By the way, the idea is not only which one you choose the best one. I'm interested in the one. D. That's why.
I will think explanation for each one and all of the parts so that they
Thank you. Thank you. I like this. Yes, sir.
I will just see.
Yeah.
Reason is that, for instance, I like the fact that there's a 0.6 and a 0.565, because if you don't understand decimals, you might think that 565 is more than 6, so you might use that order. So it's the kind of potential for error that I would try to test.
All right. So I can hear where you're going. You say because the other one, you might take 565, 0. Whatever is bigger than whatever. Okay.
I would take C also.
Yeah.
That way my OCD students would put it as 25, then 425, then 565, then 06, ordering them by the first digit.
All right. So they will ignore the commas, and then they would say 6, 25, 425, 565. They will put it there.
06 would be the last one.
The 565 will be the last one. Okay.
No, 06 would be the last one because it's got the largest leading digit.
Okay. Okay. So they will start with 565.
Oh, the 0. No, yeah, I would give it the 0.
Yes. Yes. Roberto. No. Ernesto.
Very nice about this thing.
It depends.
Different kids.
Yeah.
Different kids have different ages, different levels of education. So,
Your philosophy is going Select one. See whether they can bring the same one. Put it that way. We do what that you need to know and it will help you choose. Maybe let's think about it. What is it that you need to know? To help you choose it.
I would choose A because it's like the normal numbers which can be like ages of the children, so that you can imagine it something.
Okay, but what do you get that? What do you think that what do you need to know to be able to choose one that will help you? Which is one that children can't just read and still get it correct, just by chance, but they really don't understand. Do you know what I mean? Like, and you can't read. What do you need to know? Yes, sir.
The prices. I don't know what is the currency in South Africa. It could be dollar.
Okay.
No, exactly. Cost ticket, cost candy, cola.
Okay, so you can use prices for things. Imagine, yeah. What would you imagine?
I think the understanding of, like, maybe they don't understand the weight of a decimal compared to the
Think you get it there. Yeah. You know, here's the thing. What you need to know actually is the common errors that children make. Okay? And often, young people struggle with differentiating, understand just the role, place value in decimal. So you have to think, okay, if they don't understand what the comma is there, what it means, whatever, can they, if they ignore the comma, can they get it? And actually, one of those, they can get it right if they just ignore the comma, just wait it. So you want to think, look at the misconceptions that young people come with, and then you try to select a group that will make sure that if they have that misconception, it will show up. You wanted to say something?
No. But now, because I was going to say, I ignore the comment, but now.
Say that again. It's a bullet and phone numbers to get it wrong. Yeah, absolutely. But let's go past this one. Let's try another one because this is not so basically what I'm trying to say is that a mathematics teacher, even just in terms of teaching, they have to think very carefully about examples they give and tasks they give. It is not trivial. And to think about that, they really have to think about what kinds of misconceptions can occur with these kinds of approaches. Let's see with the wow, what's happening with your why is it not responding to me? There we go. Okay, there's another one. Okay, now a 7th grade learner, and so this time it would be great. They were asked to simplify 5x plus 2 plus 3x minus 7. And they did the following, and they got that as the answer. Is the answer correct? What? You say no. What? And how do you explain it?
He solved for X, they did it simplify the expression.
Okay,
They
what's
were
their problem?
probably using an expression and then,
Aha.
so they were probably used to, oh, we have set this expression equals 0 and that's how we solve for an equation to get X.
Yeah.
So we have to like explain this simplifying this solve.
Yeah. Precisely. So that is confusing expression. They changed the expression to an equation and they just did their own. Okay, that's easier to find, right? Good job. Yeah.
I think it's completely correct.
Oh, completely correct. Yeah.
Because what is so steps.
You are. Yeah. Nobody said it because of that. Are you telling each you want to show us? Why you asking me to go to it? Wait, and just do so for X. Right? So you changed you solved a different problem, not the one that you were asked. Right. I just have to keep, yeah?
But on the way of doing that, it simplifies the question. Then in a simulation hypothesis, solve the question but you are the teacher and you teach some examination. How do you grade? What have to grade the nevertheless, after I'm saying, what is that?
You saying the mathematics is correct?
Not only that,
Yeah.
in the process.
Yeah.
It's,
Yeah.
how would you grade?
How would you grade it? That's another struggle of a mathematics teacher. How do you grade it? And I guess it also depends. That us in the class, in the homework, in the exam, you know, because usually the teacher will make a decision based on the stakes, how high are the stakes, and then is it. But surely, I want to correct that to the child. I mean, and I'm being an engineer. You don't want to reaching the expression zero. I mean, there's absolutely rigid that oh, I mean, that. Yeah. This is just imagine. The building a bridge. But here, but the issue is what is at stake if the child doesn't understand the difference between expression and groups? You know, and what does it mean if in fact seventh graders think that every equation is equal to 6? Because that's another thing that's coming in there. What does it mean if you think that every equation is equal to 6? But the teacher has to grapple with that. I want to move on to the next. I can see that we've got 20 minutes. Here's, I've got 2 more and I'll honestly talk. So here's another, and I'm just giving examples of the things that teachers have to engage with that go beyond mathematics, that make mathematics hard. It's not everything. So here we've got 2 learners, Dave and Teko, and they want you to help them resolve an argument that they have about the following statement. The diagonals of a rectangle bisect the angles of a rectangle. Dave says the statement is true, and Teko says it's false. Explain to each of them why their answer is correct. This one, by the way, you can give it to your students in there. But you could have students arguing furiously about it. But a mathematician doesn't have to worry about this. You just tell them the right answer and go away.
Your students know trigonometry. Do these students know
No. No, I think that's what we said. And see.
Yeah, well, it's a window process about switch.
Yeah. So remember the question, we've got to explain to Dave and to Teko why they. You don't just give only the class.
But rectangles aren't always necessarily square, so the shepherd would be correct in the other situation. So I
guess Dave would be wrong if the statement were changed to the diagonals of rectangles being rectangle. But since the statement is made
Technically, they can both be correct. Wow. Are you going to do it?
very hard.
Brilliant. Brilliant. There's nothing to add. Okay, I think this is the last one. Let's think about Mr. Scott's. Huh? What about? Huh?
This is like my students who get mathematics in the numbers, that's not their home language. They see a problem like that, they jump next. But if you come to Nora Kawan, cannot be for students who learn mathematics, the numbers that's not their home, because many of them say, that's too long, I don't want to do this next. And of course, many teachers in bilingual classrooms will not even give them such a problem, because they say they're not going to be able to. You know, because and then they then lower the demand. But I mean, if you in a programming, the problems are down. Well, this content is a little bit easier than the actual content, but it's exactly what you say. The students look and they go, you know, next. In my country, I learned mathematics in a second language, third language, seventh language text. But we'll talk about that tomorrow. All right, so Mr. Scott's class, we're learning to verify the equivalence of expressions. He asked his class to explain why the expressions A minus B plus C and A minus B minus C are equivalent. Some of the answers given by the learners are listed below. Which one comes closest to explaining why A minus B plus C and A minus B minus C are equivalent? Oh no, let's hear other words. I'm gonna come to you.
E would be correct because the other options don't make sense. Like for example, C says that if we push it in property, negative B plus C equals A minus B minus C, but that doesn't make sense because it would be A plus B minus C would equal it. But E makes sense because the negative in front of parentheses basically means that you multiply the B plus C by -1.
Yes, but remember that the question is must choose which one comes closer. E comes closer. Distributive property. Yeah, let's see. You want to say something? Thank you. Huh? The same answer, and the different answer. When you got the answer, move on.
I would be in between B and E because they pick arbitrary numbers. It doesn't really matter what you would put here, and this would get the same either way. But if you had a different case, it might possibly work differently depending on what numbers you put in. But so I guess I feel like E would be more correct than B because in a different case, plugging in random numbers might help.
So E would be more correct than B.
I think so.
So you are agreeing with her?
I guess.
Okay. I thought you were saying B would be more correct than C, than E.
I think they're both equally correct.
Yeah? Yeah. Yes.
I would go with E because even though B works for them in this case, I would explain to the student that one example is not enough to prove that it is.
Yeah. Good point. One example is not good enough. We've got future mathematicians here. Future mathematicians in the room. Yeah. Why not the associative property? Why distributive analysis? Can someone explain to us? Why are you going for that one and not the other? Yes, ma'am.
I think it's because when we, I think this problem has more to do with distributing credit time rather than improving the different terms. So I think associative would be, if you said parentheses A minus B plus parentheses minus B equals A minus parentheses B minus C plus parentheses. I think that that's where it would be more appropriate to use associative, but I think, again, the question has to do with what do you use negative and then decide two terms that are in the present. Does that make sense?
So you agree that the saying E is much more closer to correct than saying C.
Yeah, he is the appropriate.
Okay? You had your hand up? No, you don't. Okay. All right, so that was my last. So basically, what the point that I'm trying to make, the range of these examples that I'm putting up there, is to show you that mathematics teachers' jobs is not just to prepare from the textbook what they have. They've got to think about many other possibilities. We haven't even gotten to the point of having 5 different solutions. I mean, I'm trying with the 5, things and say which one comes closest. And we are not even getting to the point of solve. How do you solve the problem of a child who said, substitute A with this, B with this, C with this? How do we solve that? Because that becomes the task that the mathematics teacher gets faced with. It's not a task that a mathematician gets faced with. Yes.
Can you show them the example that doesn't?
Oh yeah, you can show them an example that doesn't work, but how does that help? Yeah.
The point of the problem is to find what they are. Later, people see that it works no matter what.
Right. You kept hands when she said that. Because this is a big idea in mathematics. Like this. Do you want to explain to? I mean, they're correct. You want because you kept hands. Yeah, you were not.
I'm their teacher.
Oh.
By example, we can only use like count speed for something. And so I was just like very proud of being about the girl
Right. Very well. That's a good example of what you did. I saw the way you took out. She's got the big idea here. You can just that's the big idea. That's the big idea. But that's the thing, right? So you want to solve this problem, but it's not specifically to helping them just with this one, but to understand that simply just because one example works, it doesn't mean, and it's not only in this kind of problem, it's in any kind of problem. It doesn't become the truth simply because it works in a specific case. It's got to work in all cases. All right, so I want to end here. I think everyone agrees with me that mathematics is easy, teaching it is hard. You know why? Because the people who've been talking the most are students, are young high school kids. Mathematicians are quiet because they're taking all this very hard. And so I want to end my talk here. Thank you very much for listening and for engaging.